everyone. Today, we're going to pull back the curtain on one of modern Java's most powerful features, Lambda expressions. And more importantly, we're going to talk about the functional interfaces that are the real engine making it all happen. If you've ever seen that little arrow syntax and wondered, how does that actually work? Well, you are in exactly the right place.
So let's just start with this big question. What's the secret sauce? What really powers the clean, concise, and honestly just more readable Java code that we see today? Well, a huge part of the answer lies in a massive shift that happened with the release of Java 8. You know, when Java 8 came out, it wasn't just another update. It was a total game changer. It didn't just add a few new things. It introduced a whole new way of thinking about our code, all centered around these things called lambdas and the functional interfaces that bring them to life.
So to make these newfangled lambdas actually useful, Java gave us this fantastic toolkit right out of the box. It lives inside the java.util.function package. And the best part is, they're predefined, which means the brilliant engineers behind Java already wrote them for us. No more reinventing the wheel for common stuff.
So what even is a functional interface? It's actually super simple. It's just an interface that has exactly one abstract method. Just one. That single method is the key because it creates a perfect, unambiguous contract for our Lambda expression to fulfill.
Okay, so this toolkit has a bunch of different pieces, but here's the good news. You can get incredibly far. You can do most of what you'll ever need by just mastering 4 of them. Let's call them the core 4. These are the absolute must-knows for any Java developer today. And here they are, the superstars of the show. We've got the predicate, which is for asking yes or no questions, the function, which is all about transforming data, the consumer, which performs some kind of action, and the supplier, which just provides values. Let's dig into what each one of these really does. To really make this click, let's try a little mental model. Instead of just memorizing names and methods, let's visualize how data actually flows through these interfaces. Let's picture them as little processing boxes. See, this visual makes it so much simpler. A predicate, you put something in and it spits out a true or false. A function, something goes in and something new comes out the other side. A consumer just kind of eats the input. The value goes in and that's the end of the line. And the supplier is the total opposite. Nothing goes in, but it creates a value for you out of thin air. All right, theory is great, but let's be real. Code is where the magic happens. So let's move on and see exactly how each of these core interfaces looks and feels in a real example. First up is the predicate. Its entire job, its whole reason for being, is to evaluate a piece of data and give you back a Boolean, true or false. Simple as that. Think of it as your go-to tool anytime you need to filter something. So check this out. We're defining a predicate called isEven. That little lambda, n goes to n%2 equals 0, is the logic. You call its test method, you give it a number, and boom, you get your answer. And where do you see this all the time? Inside the filter method of a Java stream. It's literally deciding which elements get to pass through and which ones get kicked out. Next up, we have the function. This is your little transformation engine. You give it an object of one type, it applies some rule to it, and it spits out an object of another type, or maybe even the same type. It just changes things. Our function here is pretty straightforward. It takes a string and returns an integer, specifically the length of the string. Its method is called apply. And if you've ever used the map method in streams, guess what? You've been using a function this whole time to transform every single element in that stream. Now for the consumer. This one feels a little different at first. It takes a value as an input, but its job is not to return something new. Its job is to do something with that value, like printing it to the console, logging it, or maybe saving it to a database. It consumes the value. Right here, our consumer is a simple printer. It uses the accept method to take in a string and just prints it out. This pattern is exactly what the for-each method uses at the end of a stream pipeline to perform some final action on every element. And last of our core 4 is the supplier. Think of this one like a factory. It doesn't need any input, no raw materials. You just call its get method and it produces a brand new value for you completely on demand. This is a perfect example. Our random supplier takes no arguments. Notice the empty parentheses there. But every single time you call get, it supplies you with a brand new random number. This is awesome for generating default values, timestamps, or unique IDs. Okay, now for a couple of really useful specializations.
When you find yourself with a function where the input type and the output type are the exact same, you can be more specific and use an operator. A unary operator is basically a function TT. It transforms one value, like squaring a number. A binary operator combines two values into one, like adding two numbers together. It just makes your code's intention that much clearer.
And hey, the pattern just keeps going. For those times when you need to work with two inputs instead of just one, Java provides by versions. So you've got by predicate, by function, and by consumer. They're the same ideas we've been talking about, just with an extra parameter for more complex situations. Okay, I know that was a lot of information, kind of a whirlwind tour. So let's boil it all down into a simple, practical cheat sheet to help you decide exactly which tool to grab from your new toolkit. When you're writing your code, it really all comes down to asking the right question. Are you asking a yes or no question about something? Use a predicate. Are you transforming a value into something else? That's a function. Are you just doing something with the value and that's it? That's a consumer. Do you need to generate a value from scratch? That's a supplier. And for that special case, transforming a value but the type stays the same, reach for an operator. And one final pro tip, especially for those of you who care about performance, Java gives us specialized versions of these interfaces for primitive types, like int predicate or double supplier. They work the exact same way, but they help you avoid the performance costs of boxing primitives, which can really matter in tight loops. And that's our tour of Java's functional toolkit. By really understanding these core interfaces, you can write code that is so much more expressive, way more concise, and just more powerful. So the question I'm going to leave you with is this. Now that you have the tools, what's the first piece of your own code you're going to go simplify?